Well, hey guys, welcome back to another episode of Automotive Insight. You know, the channel's been around now for a little over 2 years. We just surpassed 1 million total views.
And that's 1 million views, or that's 1 million apologies that I still have to make up for.
And the one thing that I've really caught me off guard about the people who watch this channel is how far apart they are in terms of their knowledge base. I figured we would kind of just be catering to your average DIYer, but we've got people that are master techs that watch our channel, and we got people that can barely spell cars. I mean, their knowledge base of vehicles is so low, and we take it for granted that people kind of just know the things that we know. So we're going to be getting back into our Back to Basics series on voltmeters. So some of you are going to find this remedial. By all means, go find another one of our videos to watch instead. But today, let's talk about just the basics of voltmeters. So they're technically called digital multimeters. You kind of hear them, like I usually just say grab a meter or grab a voltmeter.
Or DVOM, digital voltmeter.
Digital ohm meter. And they make them in all shapes and sizes. This is a super cheap. I think it was like 30 or 40 bucks from Lowe's. This is a Snap-on. I'm sure it costs $700-800 or something. That actually does less than what this one does, but they tend to be pretty
This one's
accurate.
also graphene, so it's a smaller oscilloscope, but anyway.
But you can get by with at least the majority of things that we do on this channel. You can use one of these, or we'll do this, or like a scope or something.
Now, I would definitely stay away from the $10, $15 ones. That's
from Harbor Freight.
Yeah, or even the $5 bin at the parts stores that they used to have. They're probably $10 bins now, but
so
anyway.
When it comes to signals on a car, 99% of them are going to be DC voltage. And most of the time they're going to be between 0 and about 14.5, 15 volts. So you don't have to get anything crazy until you start getting into hybrid stuff. And if you're getting into hybrid stuff, you ought to know what this is already. So on a car, the things that you're going to be checking with this are voltage. You can do quite a few different things with voltage. You're going to be checking amperage. Same thing. There's quite a few different things you can check using amperage. And resistance. Resistance, that's typically going to be either a component test or like a whole wiring and component test to see what's going on with that. But we'll show you how to get into all that stuff using both of these meters.
So one of the most common settings that you're going to be using is the DC voltage. It's the one with the V, with the straight line and the dash line above it. That is stands for DC current.
Direct current.
That is what you're going to be using mostly on vehicles.
There is almost no AC stuff that you're going to be checking with a meter on cars. I mean, technically an alternator is an AC, but they chop it off to make it DC. There are some sensors that produce AC voltage, but this ain't going to help you with that. You're going to need a scope for that. So most of your settings are going to be on DC and the DC voltage.
And most of the time, it's usually your simpler diagnostics, like switch components, headlight bulbs. You can check your battery, your alternator, fuses. It's sort of the simpler things is probably what this will be used for. So at the bottom of the meter, you have, this one has 3 different locations. This one has 3 different locations as well. Mine's a little bit different because I have a second slot for the oscilloscope. You can see 2 different patterns that way. But one is going to always be your ground. The other will be your DC voltage side, which you also use for your ohm meters and most of your other functions. And then on this one, it has a third option, which is a low amperage fused side, and then the other is a higher amperage fused side for the positive.
And a lot of times they will be labeled common. Common is going to be, you're generally going to have one lead in common at all times. That's going to be the ground on your voltage side, and that is going to be one leg of your amperage side or your resistance side. But yeah, common. I think this one's labeled, yeah, common. I don't know if his is or not, but
mine's labeled ground, GND.
Right. So let's get into showing some tests that you do with voltage. So in our first scenario, let's say that the customer's concern was that the left front high beam either didn't work or was dim. First thing I would do is I'd grab a meter, and in this case, I'm going to put the negative on the common. That's also, you can see the little ground signal for it. And we're going to put the positive on the side with the volt on it. So this positive here is for volts, ohms, milliamps, and diodes. And then I'm going to swing the meter over here to, this is the direct current side, the solid line and the dash lines. And since this is a 12 volt system, I'll stick it on 20 volts. So I'll turn the lights on, and I'll come over here, and I've got my negative lead on battery ground, and we're going to check to see if it's got power and ground here. So there's nothing right here, which means hopefully this is the ground. And here we have 12 volts. Now, the way to verify that this is a ground is take your negative meter lead and stick it on the positive side, and then come over to that same pin, and now it shows negative 12 volts, which means that this is a ground. So that means that you have power and you have ground, which means you have a blown headlight bulb. So a few things. You don't have to disconnect this bulb to do this test. We're just doing it because it's easy to do. But if you were checking, say, if you wanted to check like a mass airflow reading or something, you can just back probe it. Not with this lead, but they make small leads or whatever. And you can do it with the component still plugged in. It's not going to affect the voltage that it's getting. And the other thing is, these are really fat. So don't go cramming this thing in here and spreading the terminals out. All you got to do is just barely touch it, and you'll get the reading that you need. Now, the last thing we'll do is, this is a way to check for like a parasitic drain test. If you were working on like that car behind us over there, that Camaro, and it had a parasitic drain, usually what you do is you just go pull fuses on it, and whenever you pull the fuse that causes the drain to go away, you at least know that that's what circuit it's on. But nowadays, there's so many computers on them, and they're staying awake and doing all kind of stuff. You don't really want to pull fuses if you don't have to. And plus, you might accidentally fix it by doing that, or at least make the problem go away until another time that you're not ready for it. So what you can do when you're checking for a parasitic load nowadays is you can actually voltage drop across the fuse. So I'll show you what that looks like. Basically, we have our meter back in the voltage setting, and I've got it on the lowest setting that we have here, which is the 2 volt setting. We're just going to keep using our headlight circuit. And so you can see it kind of moves around and stuff right now, and that's normal. I mean, this is a cheap meter, but even on like good flukes and stuff, it'll do that. But if you come across your meter leads across a fuse, you have 0.023 volts. Now, if you go online to like PowerProbe's website, you can pick the size of the fuses. Like, you can pick the fuse that you have and what you're measuring across it, and there are charts that show you how many amps that equates to. So that's a way of measuring current draw on a circuit with a fuse without interrupting that fuse, and it's pretty accurate. I mean, it'll get you in the ballpark of where you need to go when you do that. So the next thing you're going to use this for would be amperage. And so if you wanted to, say, try to find a parasitic load, or see how much amperage a high beam or something is pulling, you would use the amp setting. Now, in order to do amperage, you have to actually be in series with that circuit. Whereas with voltage, you're going to be on a ground somewhere and on some type of voltage line somewhere else. You can do it kind of in parallel with it. And amperage, you have to disconnect that circuit, and then the current is going to flow through your meter. So if it's something that you don't know what it is, or if it's something that is, blowing a fuse or something, your best bet is always to start higher than what you need. So if you had like a parasitic load, I would put this on the 10 amp setting, even if you only have like 1 amp, because the other setting is for down to 2 milliamps. So most of the time they have 2 fuses inside of them. So if you start with the low one and you blow it immediately, you're done till you get another fuse. So it's always easier to start out higher and then work your way down once you see what it is. But at the end of the day, you have to be in series in order to measure the amperage with that. All right, so now what we're going to do is, let's say that this fuse was intermittently blowing or something to that extent. You needed to measure the current on it. So what you can do is we just pulled the fuse from the fuse holder. We've got our meter now. We set it. We still have our common. It's always going to be in place. And then I moved it over here to the 10 amp side. This is a 15 amp fuse. It's probably not going to draw that much, but it's a 15 amp fuse. So we can run our meter. Our meter is basically going to act like our fuse, and we can measure what the current draw of this headlight bulb is. So we'll put one lead on the one side. We'll get the other lead. I might be able to, there we go. And we are now measuring almost 5 amps. And if you look, now our headlight bulb is on. And now as soon as I disconnect the meter leads, headlight goes out and we're back to 0. So that's how you would do an amperage check.
One other common function is the resistance side. I believe that's the omega symbol. So checking resistance on the system, you have to isolate the wire or the part you're checking. You can't have power on it because the way I understand it, resistance, the way it checks it, it sends out a small amount of voltage and it gets that reading back, and then it calculates the resistance that way. So there's a little bit more, checking resistance is a little bit more involved.
To be honest with you, I don't really like checking resistance of things if I don't have to, because resistance is going to vary a lot based on temperature. The hotter electrical components get, the more resistance that they have. And so if you've got a transmission shift solenoid problem, you'll look in the repair manual and it'll say, once it checked at 78 degrees Fahrenheit and the car's at 180 degrees. So even if it's fine, the resistance is going to be higher than what the spec says that it should be anyway. Another reason I don't like it is because you can basically accomplish the same thing with a voltage drop test. So resistance, the only time that I use a resistance check is when I am checking to see if a CAN network is intact. But other than that, I generally speaking don't use resistance checks that much. There are better ways to do things. Because
there have been cases where the resistance was low, but it was just had a couple good strands that weren't broken, and it still wouldn't be enough to carry the current.
Well, I was going to say, it's not. A lot of times, if you've got like a chafed wire, and let's say there are 10 strands in that wire, you could have one strand still intact and go to check that wire from point A to point B. It's going to have resistance. It's going to have whatever the right resistance is, more than likely on it. But that one strand can't flow the amount of current that the 10 strands would. So I don't really care for resistance. It is better than nothing. I mean, if you've got a component that is open, then yeah, that'll help you find that. But anyway, let's get to a car and show you how to do some of these tests. If we had 7 volts here, that would tell us a couple things. Number one, it tells us we obviously have a voltage drop somewhere. We're dropping between 5 and 7 volts from wherever the power source is to here. So what you could do then is you could go to your, turn the headlights off. You could come down here to your power and go to where your fuse is and check resistance. So here we have 0 ohms, but if you had, say, 400 ohms or 4,000 ohms, you know that you have some kind of resistance between the fuse and your connector here. So then you would start trying to track that down as to where that was. But this just goes to show you that both resistance and voltage, you can kind of check the same thing doing it either way. So and in order to do that, I didn't have to do anything on the meter as far as the leads go. All I did was I just swapped it down here to 200 ohms. Your resistance isn't going to blow anything up, so you can move it to whatever setting you need, but I just picked the lowest setting, which is 200, and that worked out just fine.
So with not much to contribute to this video, that's going to wrap it up. Only thing I bring to this video is probably a good looking beard. Maybe not today, but anyway, that's going to wrap up this video. Multimeter functions, multimeters still are very useful, even though it's kind of, there's not very many, you're still using the basics. I have them. I even have a power probe that makes certain tasks a lot easier, but a good basic multimeter is a must-have in the automotive industry.
And you're still going to need other things also, like we were talking about with the broken strands of wire and having like one strand left. Same thing with as measuring resistance across it. You're also going to be getting like 12 volts or whatever the voltage is. It can't carry the current. And so that's another thing that you should do when you're, let's say you're down checking a module or something and you're checking for powers and grounds at your module. You want to load test that circuit as well. So we did that in our BMW air compressor video. We ran a high beam bulb off the powers and grounds because, yeah, you might plug it in and have 12 volts, but it can only carry, 1 or 2 amps, and it's a 20 amp circuit or something like that. So
yeah, I've been burned by that.
Yeah. So, but yeah, a good meter, and at work I use Fluke. Fluke is pretty much the gold standard. I have been led down the wrong path using a cheap meter or a meter that was going bad in the past. But for most things that you need, something like this is going to work. For like DIY type people, this was going to work.
Spend the $30 to $50 for a meter.
Yeah, I mean, you don't have to buy a $200 or $300 Fluke for this, or a whatever $400 or $500 Snap-on for stuff like most of the stuff that you're going to do. But yeah, something between 30 and 75, 80 bucks or whatever. Yeah. It's going to be fine for the bulk of what you need. And like I said, it's not going to check. You're not going to be checking crank sensor voltages with it. So they have their place, and I use mine a couple times a week. I tend to default to power probe just because it's a little bit more convenient, but I'll bust a meter out, a couple times a week to check voltage drops and stuff like that. But anyway, guys, that's going to wrap this one up for today. Hopefully you earned a thumbs up from you. Let us know what you think down in the comment section. We have new content for you every single week, so consider subscribing to the channel. And with all that being said, thanks so much for watching. We'll see you on the next one.
May not have all your answers. Hopefully I had some. That being said, see you on the next one.
I'll pick you up at 8. You probably won't be awake. Call yourself an Uber, babe. I'm gonna wait. I'm gonna wait.
It's the surface of Mars. Or is it? Blink.